Hello. In our previous lesson, we talked about f having the derivative of our function f at some fixed point a. Well, we can also consider that our function f has a derivative at all these varying points that we'll call x. So I'm looking at the derivative of f at some varying point x. Again, a is fixed at one specific point, x is not. X is our variable. So we have a brand new function we're creating from our original function f of x, and it's the derivative of f. And we use our same formula, this limit that we had, in order to find it. So the limit as h approaches 0, but it's the limit of f of x plus h minus f of x all over h. So we're going to use this formula in order to find the brand new derivative functions from our original functions. So let's try that on the next slide. So we have our function f of x equals x squared minus x, and we want to find the derivative of f. So we'll use our limit formula. So the derivative of f of x is the limit as h approaches 0 of, we'll do our f of x plus h minus f of x all over h. So I'll color coordinate this again, as you can see. So the derivative of f of x is our limit as h approaches 0 of, and so f of x plus h means we're going to replace all of our x's with x plus h in the function. So instead of x squared, we have x plus h squared minus, and instead of x we have, again, x plus h minus, and then we have f of x. And f of x, we replace all of our x's with x, well, it just stays the same. So x squared minus x all over h. And we want to go through and simplify this. So the f of x equals the limit as h approaches 0. X plus h quantity squared, that's x squared plus 2x times h plus h squared minus x plus h, so I'm going to distribute that through, so it would be a minus x minus h. And then I have a minus x squared minus x, and I'll distribute that minus through, so for a minus x squared plus x. And that right now is still all over h. And if we did this right, a whole bunch of things should cross out. X squareds minus x squared, gone. Minus x plus x, gone. And so you can see here, we're going to have our limit of 2xh plus h squared minus h all over h. And once again, we can cross some things out here. We have an h on top and bottom. We have an h in all of our terms. And so this minus h, when it cancels, becomes a 1. And so this is the same as the limit as h approaches 0 of 2x plus h minus 1. And when we do our direct substitution by putting 0 in for h, that's going to go away, and we just have 2x minus 1. So the derivative of f of x is 2x minus 1. And that's how that is done. And for now we are finished.